Everybody, this is Mr. Beckstrom, and today I wanted to go over a problem from section 7.5, and this is one of those tangent problems, and I think a lot of us are having trouble getting the final answer. There's a lot of algebra involved. So let's go ahead and take a look at this. We want to find the tangent of alpha minus beta. I'm just going to use A and B to make it a little bit easier. Here's the formula. Formula is, and let me go ahead and get my pen ready. The tangent of A minus B is equal to tangent of A minus tangent of B all over to 1 plus tangent of A times the tangent of B. Hopefully by now you know how to get the tangent of B just using the cosine of B and the fact that you're in the first quadrant. You can either use the Pythagorean theorem to find the cosine or the sine of B and then use that to find the tangent, or you can use triangles, but I'm not going to go through that. I just really want to kind of go through the algebra of this part. So the tangent of beta or B is equal to 1 over the square root of 3, and that's going to be positive. All right, so let's kind of go in and do this one because it is kind of a beast here. So substituting everything in here, we're going to have negative 12 over 5 minus, and this is going to be 1 over the square root of 3 all over 1 plus negative 12 over 5 times 1 over the square root of 3. All right, give myself some more room here. And then we're just going to get some common denominators and work this thing through a little bit. So we should get, oops, make sure this is right. Negative 12 root 3 over 5. This is multiplying the top and the bottom of that by root 3 minus, and then multiply the top and the bottom by 5 over root 3. And then for the denominator down here, multiply the 1 by root 5 over 5 root 3 over 5 root 3. So we get 5 root 3 all over 5 root 3. And this is going to end up being minus, multiply those fractions across, and we're going to have 12 over 5 root 3. All right, move that up a little bit. So then combine those together. We're going to have minus 12 root 3 minus 5 all over, oh, I forgot to put the 5 on the bottom down there, all over 5 root 3, and this is going to be over 5 root 3 minus 12 all over 5 root 3. Now I have the same denominator on both the top and the bottom. I can basically just multiply the top and the bottom by 5 root 3 to cancel those out, or you can multiply the entire top by the reciprocal of the bottom and those will cancel out. But this is going to give me the negative 12 root 3 minus 5 all over 5 root 3 minus 12. So this is where we should be, and my math lab may take this right here, but with the amount of emails that I'm getting about this problem, I guess it's not taking this. Sometimes it takes it in this form and sometimes it doesn't. So if it wants you to rationalize this denominator, which means that it doesn't want a square root in the denominator, this is what we need to do. You need to multiply the denominator by the conjugate of that denominator. So the conjugate of a binomial is you take the same binomial terms, so the 5 root 3 and the 12, you just change the sign in the middle, and that gives us a difference of squares. So when we multiply by the conjugate, then and you FOIL it out, you get the first term squared minus the last term squared, and it's really nice in that it cancels out, or it gets rid of our square roots. So that's what we're going to do here. We're going to multiply the top and the bottom by the conjugate. So 5 root 3 plus 12 and 5 root 3 plus 12. All right, so on the bottom here, we're just going to end up getting, we're going to end up doing the first thing squared. So that's going to be a 25 times a 3, so that's going to give us a 75, minus a 144. Oops, don't move, please. 144. 144. And then on the top, we're going to have to FOIL this thing out. So on the top, I'm going to get a the first term squared. That's going to be negative 60 times 3. So I'm going to get a minus 180. And then I'm going to get the inner terms, which will give me a minus 25 times the square root of 3. The outer terms, which will give me a minus 144 times the square root of 3. And then the last terms, which will give me a minus 144. This is doing this binomial here. And then cleaning this up here, I'm going to get a negative 240 minus 169 times the square root of 3 all over negative 69. And since everything's negative, we can just multiply everything by a negative 1, or multiply the top and the bottom by a negative 1, and that's going to give us 240 plus 169 times the square root of 3 all over 69, and that is our final answer there. So pain in the butt. I hope this helped. If you have any questions, let me know. Thanks.